Okay, so today our agenda is 3D Mohr circle. Okay, so some of you might say, Eugene, I'm not so sure about 2D Mohr circle. So if you're not so sure about 2D Mohr circle, go to week 11. Okay, week 11 on a Thursday. This is about 2D Mohr circle. So I did briefly, okay, not briefly, I did talk about 2D Mohr circle before. So you guys will have done 2D Mohr circle. Even some of you can't remember. Okay, just go back to this week 11 Thursday lecture on the recording. You can recall how to do 2D Mohr circle. Okay, so now we're going to do 3D Mohr circle. Okay, before we do 3D Mohr circle, tomorrow, April 9, I'd like to inform you all 9:30 to 10:20, we're going to have a lecture on example of 3D Mohr circle. 2:30 to 4:20, again lecture about U criteria. Okay. Put your calendar on the side. Okay. Revision, April 15, 2:30 to 3:20. April 16, 9:30, 10:20, 2:30 to 4:30. Can anyone tell me, are this time good or no good for you all? You all have a test or an exam? Anyone? Or you all don't know yet? Anyone?
I think the math exam is that morning, the Friday.
Which? Oh, Friday morning. Okay, don't worry. I will record
I'm not mistaken.
Yeah, Jacob, don't worry. Okay, I will record. Okay, if you have question, you all cannot make it for 9:30, 10:20. Give the question to your friends to ask, and I'll. Is it everyone, Jacob, having the math, Jacob?
I'm pretty sure. If anyone can confirm, like I think everyone has math. Like unless you already took math. But I'm pretty sure the exam's that Friday.
Okay. Anyway, I'll still run at 9:30, 10:20. I'll still record it. Okay. So after your math, okay, have a good drink or get something to get high. Still come for my revision. Okay. Right. Anyone? Any questions so far? No. Okay. Here we go. So we are going to do 3D Mohr circle. Okay. So 3D Mohr circle now. 3D Mohr circle is just 3 circle. Okay, 3D Mohr circle is not a sphere. Don't tell me, Eugene. Where are we going to draw a sphere? The answer is no. So 3D Mohr circle. Okay, 3D Mohr circle is used to determine principal stresses in compound loading or during compound loading, okay, or under compound loading. So you guys have done a lot of compound loading with me already, okay? So compound loading is not over for you all yet, because when you go to 3E, more compound loading, okay? So my notes, my lectures will be made available online. So once this class ends, okay, you can access my notes to you graduate from McMaster. Okay, my advice is just download everything. You might need it for work if you become a design engineer. Okay, so that's my hope. So in 3D, we are no more dealing with a square. Okay, we are looking at a 3D space now. Okay, so 3D space, X, Y, and now we have another axis Z. Okay, and I'm going to show you. I'm going to show you later. Sometimes it's okay to do 2D analysis. Okay, most of the time it's preferred to do 3D. Okay, when I was an expert witness, a chief engineer just used 2D, underestimate the stresses. Okay, by using 2D, by right he should have used 3D. Okay, so I'm going to show you all what I've done. Okay, to prove the hypothesis why 3D is important. 2D fundamentally is also critical. Okay, so as I said, you need to know when to use what. Okay, which I want you to learn. Right. So now in terms of 3D now, as I said, we are now handling a cube. No, I mean, yeah, it's not a cube that is square on all sides, okay? or equivalent all sides. Okay. So when that's the case, how many force components we have now? Okay, so I'm going to draw our force component now. So you have our stress in X. And a bit of good news, when it's 3D Mohr circle, it is not 3 times more difficult than 2D Mohr circle. It's not, okay? It's just a bit more only. Right, so you have your normal stresses over here, okay? Then you're going to have your shearing stress, okay, your shear stress. So your shear stress will correspond to, you have one shear stress here. So this is shear stress, okay? The intersecting plane is, the plane is intersecting the x-axis. The shear force is going, or the shear stress is in the y-axis, okay? So over here, the shear, right? The plane. So this over here, the plane, what do I mean by the plane? So this is the plane, right? The plane intersecting the axis. So the plane intersecting the axis over here, it intersects the what? Y-axis. So y over here, and this the force direction or the shear stress direction is in the x direction. So that's how it's labeled. Okay. So I've done that before. Just a quick refresher for you. Then we have over here, you have a different plane now. So you have some more shear stress over here, right? So the shear stress that I've drawn over there, so this is the intersecting plane again is in the x. Okay, so for this case, the intersecting plane is in the x, but the shear force directions is in the z. Okay, likewise for the other side, the intersecting plane in the axis is the z. The shear stress is in the x, and then the final one that I'm going to draw is this one over here. Okay, so again, this is the intersecting plane is in the z, and the force is, the shear stress is in the y. Okay, likewise. Okay, so as like before, not like before, maybe I'll do a quick recap for you guys, that shear xy, or I'll call it the state of equilibrium. Shear xy is equal to shear yx. Shear xz is equal to shear zx, and shear yz is equal to shear zy. Okay, that's what we call the state of equilibrium. Means the deformation or the loading of the structure has been stabilized. Okay, right. So then I'd like to talk to you guys about a term that you all will see. Some of you might be taking finite element course, which I really find very, very useful. Okay, so I'm going to tell you there's a term known as plane stress analysis. Okay, so when you come across a term where it's called plane stress analysis, what does it mean? It means that stress X and stress Y is not equal to 0, while stress in the Z direction is equal to 0. It's also possible where stress X and stress Z is not equal to 0, while stress Y is equal to 0. So these are condition number 1, condition number 2, and then finally where stress Y and stress Z is not equal to 0, you have stress X is equal to 0, and condition number 3. You have not seen this before, but once you all go to 3E05 or finite element, you are asked to analyze the structure under plane stress condition. Okay, so this is what we call by plane stress analysis. Then there's another possibility, okay, which I don't think you all were touch as an undergrad, but if you go to graduate school, there's another condition we can analyze is under plane strain analysis. Okay, just quickly, this is just for knowledge. Okay, so plane, as the name comes, as you can see over there, looks like something went wrong. Hello, can you all see me? Did I black out a bit?
No, sir, because I can see
Okay. Okay, because my computer say the presentation is on hold. Okay. So over here, under plane strain, so strain in X and the strain in Y is very much greater than strain in Z, and strain in Z is not equal to 0. Okay, that is condition number 1. Okay, so as I said, this you don't see as an undergrad student. If you go to gadget school, probably you'll see. So likewise, I'll write this quickly. Okay, I don't waste too much time. So condition number 2. Condition number 3. Okay, but for this course, we are going to focus on possibility of having plane stress analysis. Okay, so some questions says plane stress. You need to know if it's declared to be plane stress. Okay, you still need to do 3D analysis, but you will know one of the stress state is equal to 0. Okay, you will know. Okay, so some of you might ask you, how do you know that you will know? Okay, the question will tell you there are 2 directions with stresses. Is you have to analyze one more that is not. For example, if I say that stress X and Y have stresses, if I say do plane stress analysis, you have to say that stress Z is equal to 0. Okay. Now, from here on, I'm going to have 3 different conditions. Okay, we are going to look at 3 different conditions. Okay, for 3D Mohr circle. Okay, and the element is oriented in the principal plane direction. Okay, so what do I mean by that? When I say the element is oriented in the principal plane direction, is where stress xy, okay, shear stress yx, shear stress xz, shear stress zx, and you have shear stress yz and shear stress zy. They are all equal to 0. Okay, so here you only going to see normal stresses. Okay, and I'm going to state 3 conditions. Okay, so with these 3 conditions, by looking at these 3 conditions, which is a foundation, you will know, okay, when you have to absolutely do 3D stress analysis. Okay, and in what condition you can just rely on 2D. Okay, right. So we are again going to look at condition number 1. Okay, condition number. Now, all this condition I drew that I'm going to draw is where the element is oriented in the principal plane direction, where all the shearing, any shear that we have, is all going to be absolutely equal to what? 0. Okay, absolutely equal to 0. So let's draw the first transformation. Okay, then the element so again you have stress X, stress Y, stress Z. Okay, so condition number 1. Okay, condition number 1 is where I should have moved this slightly lower. My apologies. Okay, condition number 1 is where stress X and stress Y. Okay, stress X and Y they are both positive, and